A very common situation is for one quantity to be a constant multiple of another quantity. And in those cases, some vocabulary we might use would be to say one variable varies directly as another variable, or the first variable is directly proportional to another variable. Or sometimes even the word directly is left out and you say one variable is proportional to another variable. In those situations, we could write our first variable is a constant times the second variable, such as y equals k times x. And that constant k is going to be what we call the constant of proportionality. It's the number that you always multiply by one variable in order to get the value of the other variable. This sort of equation is what we're going to write as our basic equation anytime we see something that says something varies directly or is directly proportional. Let's read this problem and see how this is going to work. It says, during a thunderstorm, you see the lightning before you hear the thunder because light travels much faster than sound. The distance between you and the storm varies directly as the time interval between the lightning and the thunder. Without even reading the rest of the problem, I can go ahead and write my basic equation to describe this situation. I'm going to use d for distance and t for time, and I can say d is equal to k times t. Whenever you see something say directly proportional or varies directly, your basic equation is going to be one variable equals k times another variable. Now let's read part A and see what we can do with it. It says, suppose that the thunder from a storm 5,400 feet away takes 5 seconds to reach you. Determine the constant of proportionality and write the equation for the variation. Well, here we're given 5,400 feet takes 5 seconds. We're going to plug in the values we're given to help us figure out what that k should be. Here we have 5,400 equals k times 5. To get k by itself, we divide both sides by 5, and we have 1,080 equals k. So now that we know what k is, we can go back and write our basic equation. Instead of d equals k times t, we can be more specific. D equals 1,080 times t. And now we can answer our question B using that equation we've come up with. It says if the time interval between the lightning and the thunder is now 8 seconds, how far away is the storm? We can plug in 8 for the time, and we have d equals 1,080 times 8, and this gives us 8,640. And the units we're using for distance are given up there in part A, which is feet. If you would like to solve the next problem on your own, pause the video now and resume when you're ready to see the solution. The bounce height b in inches of a tennis ball varies directly as the drop height d. So essentially what that sentence is telling us is b varies directly as d. So our basic equation for this problem will be b equals k times d. Then it says the bounce height of the tennis ball is 20 inches when the ball is dropped from an initial height of 30 inches. We're going to use that information to help us figure out what k is. The bounce height is 20 inches. We put that in for the bounce height b. We don't know what k is. We're trying to find that. It tells us we drop it from an initial height of 30. We plug that in for d. To get k by itself, we divide both sides by 30. 20 over 30 we can reduce to 2/3. So we have 2/3 is equal to k. Now we can rewrite our basic equation since we know what k is. Instead of b equals k times d, we have B equals 2/3 times D. Now we can answer the last part of the question that says, find the bounce height if the drop height is 50 inches. So we plug in 50 for the drop height D, and we have B equals 2/3 times 50. This gives us 100 divided by 3, which rounded off to 1 decimal place would be about 33.3. And our units that were given in this problem are inches.